Today I wanted to talk about operator precedence. We talked about how computers actually do operations. And if we do a simple arithmetics of adding 3 to number 10 at the assembly language level, we would have to type in these kind of commands where we take a container and we zero it out by moving 0 into like AX in this case, move 0 to BX, and then we load values. The lower half of A will get 3, and the upper half of container A gets A. A is the hex value of decimal 10. And then we add the two values together and then we start all over again. So let's trace and see what it looks like as the CPU sees it. Keep your eye on AX equals and also the IP equals values. So as you can see, move BX0 is instruction pointer is pointing to 103. That is executed. So BX has 0 in it and AX has 0 in it. Now when we moved A low 03, the register at AX has 0003 in it. When we moved A high A, that was stored in the upper half of AX 0A03. When we add the two values, then what the operating system does, the Intel infrastructure, Intel architecture does, it recycles the low half of the AX register and stores the result in there. That's why you see the 0A0D, which is the result of the operation. So this is what it looks like. A high is 0, A low is 0. A low is stored 3 and A high is stored A, which is 10. After we add the two values, 3 and 10 together, the result is 13, which is hex value D. That 0D is stored in AL again. That's for one operation. What if we have multiple operations? So make sure that you remember PEMDAS. Please excuse my dear Aunt Sally, where please is parentheses, excuse is exponents, my is multiplication, dear is division, aunt is addition, Sally is subtraction. This is the order how the operating system will evaluate the operations. Because the operating system can only, or a CPU can only perform one instruction at any given time, it needs to see which one to perform first. So when we have the problem, we need to parse it into pieces. So you can see that we have a parentheses, we have parentheses inside parentheses, so that is evaluated to 8. The outside perimeter or parentheses then evaluated to 1125, and finally we subtract the two values and we'll get 1117. Now because the parentheses are evaluated, then we go outside the parentheses and then we look at the 9 squared times 4, and then finally we divide the results. Now that is not all the operators. This table shows you all the operators that we'll see in programming courses, in programming languages. So when we look at the parentheses, the highest precedence, that's really just called the function call. So if you want to take a square root of some value, that's really a function call. So that's going to be performed first. So that's the P in please. A unary plus and minus signs then evaluated, and then we have the multiplication, division, and addition and subtraction. So that is the my dear Aunt Sally. So you can see that the M and the D, the multiplication and division, is first evaluated from left and right, and then the addition and subtraction also evaluated left and right, where first addition, then subtraction. So this is how the computer evaluates an expression. It has to parse it into pieces and then evaluate which one comes first. Now, where did we come from? When we're looking at older operating systems like Unix, this is one of the first calculators. So in order to use this calculator, you already had to parse out the expression and type it into the calculator. So you can see that here you typing in the values first and then the operation. So 5 times 4 plus, so that means add 5 plus 4 together, and then or in this case we're going to be subtracting the 7. So we're going to add the 5 and 4 together, and then we take 7 and then we're going to subtract 7 from the results. So 9 minus 7 is 2. So after P you can see the number 2. So when we look at 453 asterisk asterisk, that means 4 times 5 times 3, and that's going to be 60. So 453 asterisk asterisk, so again 4 times 5 times 3 is 60, and then 15 minus is 60 minus 15, which is 45. So it's very complex, very complicated to use a calculator like that. But if somebody knows how to use the calculator in that fashion, they will know what an operator precedence is, or how to parse an equation or an expression. So here I'm just stepping through what does that look like when we type in this strange calculator. So we have a stack, and the stack is loaded, and the first operation, which is the inner parentheses, is 14 minus 6. So we type in 14, 16 and then the operation. So that's going to have a result, and then I save it to a register for later use. And now we have the 9 times 5 cube. So there's going to be 953 exponent times. So 5 and 3 exponent. So 5 going to be raised to the third power. So that's going to be replaced with a value, and now everything shifts up, and now we have a multiplication. So now we're going to calculate 9 times 125. That's going to be 1125. Now we load what's in register A, and then we subtract it. That's going to be 1117. We replace what was saved in register A, because we really don't need 8 anymore, so we can replace that value with the latest operation. And now we're going to evaluate 9 squared times 4. 9 squared exponent 4 times. It's really strange to say it that way. Exponent is evaluated first, and then the multiplication. The result is 324, and now we're going to load what is in register A, which is the LA command, and then we're going to divide the two, and the result is 0 point some fraction. So that was solution 1. So I was only using one single register and rewriting values as I needed it. In solution 2, again we go through the same steps. We had to parse out the inner parentheses, so that's going to be 14 minus 6, which is 8. That is going to be saved in register A with the SA command. And now we need to evaluate 9 times 5 cubed. So 5 to the third power, and then the result is multiplied by 9. So the result is 1125. Everything else is removed from the stack, and that is saved in register B. Now we need to evaluate 9 squared times 4. 9 to the second power, times 4. So first the exponent is being evaluated, so that's 81. Moves up on the stack. 81 followed by 4 times means 81 times 4. It is being evaluated. The result is 324, and that can be saved for later use in another register. At that point, we can load from those registers. So LB means load whatever is in register B, and LA means load whatever is in register A, and then subtract the two. So at that point, the stack gonna have 1117. After 1117, we're gonna load whatever is in register C, which is 324. But we don't want 1117 divided by 324. We want 324 divided by 1117. So we're gonna swap the two. So that's the R exclamation command that swaps whatever is in the stack, and then we say go ahead and divide the two, and that's going to result in the same value. But in this case, you can see that there were some extra steps, extra registers, extra memory was used to do the same calculation. So the first algorithm was more efficient than the second algorithm. So the inner parentheses evaluated, then the outer parentheses evaluated, and then the operation performed. At that point, the parentheses were evaluated, and then eventually the division was made with the numerator, when the numerator was evaluated separately. So hopefully that shows you and helps you understand how the operator precedence works. See you next time.